Hello, in today's class the chapter that we are learning is Binary Data Representation Part 5, Rational Numbers. It includes binary decimal conversion, that is binary fraction to decimal fraction to binary fraction, and the concept of infinity in binary, that is infinity binary fraction. So let's do a practical session for that. First of all, what is rational numbers? We have heard this term, right? Well, any number that can be converted into fraction is called the rational number. Well, here we have 1.5. If it is a rational number, yes, we can write it like this, 3 by 4. It can be converted into fraction, right? So yes, it is a rational number. We have 2. Can be converted into fraction? Yes, it is. It can be converted into fraction like this, 2 by 1. So it is a rational number. We have root 3. If it is a rational number, no, we cannot convert it into fraction. So it is not a rational number. Now let's move to the conversion part. Here we have a number that is 9.75. It's obviously a decimal number and we will convert it into a binary form. Here we know how to convert this sign into binary, but we don't know how to convert this fraction part, that is 0.75, how to convert it into binary fraction. So we will learn that one first. So we will write it 0.75. Now we will multiply this 0.75 with 2 until we get 1, perfect 1, not less than 1 and not more than 1. So 0.75 into 2, we would get 1.5. Now here we have got more than 1.5. So we will write this 1 here. Even if we have got less than 1, like 0.5, then we would have written the 0 that would be here. We would transfer this 0 here. So this is how it is done. Now since we have got this 1 here, we are left with 0.5. There is 0.5. So we will multiply with 0.5 with 2. So we got 1, our perfect 1. So we will transfer this 1 here. We will write it like this, 1, 1, but this is from top to bottom, like this, 1 and 1. Okay? Now, we will convert this 9 into binary, and we know how to convert it. That specific format. 9 divided by 2, 2 4s are 8. And 1 remainder, 1 here, 2 2s are 4, no remainder, so 0, 2 1s are 2, so again no remainder, 0, and here 1 is less than 2, so we will transfer this 1 directly here, and here we will go from bottom to top, so 1 0 0 1, and this is our answer. Now we will do the exactly opposite. We will convert this binary number into this decimal number, and that way we will learn this binary fraction to decimal fraction conversion, and we will check our answer too. So some space necessary for that. Now we will write this binary number a bit further away. That is 1 0 0 1.11. Now let's get over with this whole number part, since we know how to do it. This one would be 1 into 2 raised to 0. This 2 zeros would be zeros. This one would be 1 into 2 raised to 3. Now 2 raised to 0, that is 1 into 1 1 plus 0 plus 2 raised to 3 8 into 1, that is 8. So we have got our 9 here. Now for this point part, after this point is 1 into 2 raised to minus 1, and for this one 1 into 2 raised to minus 2. Now just notice the difference, what we have done here and what we have done earlier for this. Well, in this case we have gone from 0 to 1, 2, 3, 4, 5, 6, so on, right? And this one is from right to left. Okay, but after this point we have gone from minus 1 to minus 2 to minus 3 and so on, and we have gone from left to right. Okay, and again this is starting from minus 1 and not from 0. This is starting from minus 1, and here this raised to started from 0. Now this minus 1, 2 raised to minus 1 is written like this: 1 into 1 upon 2 plus addition like we have done here, plus 1 into 1 upon 4. Usually 2 raised to 2 is equal to 4, and when there is minus in raised to, we just have to write it like this. We have to write this 4 in denominator. Now, so simply it is 1 by 2 plus 1 upon 4. We can do this by taking the LCM, or we can do directly the division. If we do the direct division, we would get 0.5 for 1 by 2, 0.5 for this 1 by 2, plus for 1 by 4 we would get 0.25. So our answer would be 0.75 here. And if we take the LCM, this would be multiplied with 2. So 1 into 2, 2 plus 1, denominator 4, we would get 3 by 4. And 3 by 4 is equal to 0.75. So again we have got as 0.75 as an answer. Now we will write it here 9, and here we have got 0.75. So this is our decimal number that we were looking for, and yes, our answer was perfectly right, as you can see. Now our next example. So some space. Our next example is a binary number that is 0.0001, and we will convert it into a decimal number. Here we are not concerned with this whole number part, as it is already 0 and it is going to be 0 even in binary. So okay, so we are concerned with this fraction part. So we will write it like this: 0.0001. It would be 0 into 2 raised to minus 1. This is going to be 0 into 2 raised to minus 2. This 0 into 2 raised to minus 3. And this 1 into 2 raised to minus 4. This all you have to add, but as you know, first three there are zeros, so these are going to be zeros. So one big zero for all of them, and for this 2 raised to minus 4 we would get 1 by 16, and this is equal to 0.0625. So this is our answer. I'll write it here: 0.0625. Now we can check our answer by converting this binary fraction into decimal fraction. So let's do it. Let's check if we got our answer correct or not. So we'll write it here: 0.0625 and we will multiply with 2 until we get a perfect one, not less than 1 and not more than 1. So 0.625 into 2 would give us 0.125. We have got 0, so we will transfer this 0 here. Now 0.125 into 2 would give us 0.25. So we would transfer this 0.25. We will transfer this 0 here and multiply this 0.25 with 2 again. So we would get 0.5 again 0. So again transfer the 0 here. Now 0.5 into 2. So finally we got our 1. So transfer this 1 here and this is the end of this multiplication as we got our perfect one. So ultimately what you have to do is you have to multiply this number, this fraction part, with 2 until you get the perfect one. Whatever you are getting as whole number, you just have to put that here. Okay, even if you have got 1.25, then you would have to put this one here and then you would multiply 0.25 with 2. Okay, so finally we have got this answer and we will go from top to bottom, remember. So our answer is 0.0001. 0001. Okay. So finally we have got our answer and these two are exactly same. Now let's move to another example. So some space. Now our next example is 101010.1111. This is a binary number and we will convert it into a decimal number. So we will write this binary number a bit further away like usually we do. 101010.1111. Now let's get over with this whole number part. For this 0 is going to be 0 obviously, so no need. For this 1 into 2 is to 1, 0, don't bother. 1 into 2 is to 3, this would be 2 raised to 4 but it's 0. So now this 1 into 2 raised to 5. Now for this 2 raised to 1 we will get 2 plus 2 raised to 3 that is 8 plus 2 raised to 5 that is 32. So 32 plus 8 that is 40 plus 2 that is 42. We have got a 42. Now for this fraction part 1 into 2 raised to minus 1 plus 1 into 2 raised to minus 2 plus 1 into 2 raised to minus 3 plus 1 into 2 raised to minus 4. Now 2 raised to minus 1 that is 1 by 2 plus 2 raised to minus 2 that is 1 by 4 plus 2 raised to minus 3 that is 1 by 8 plus 2 raised to minus 4 is 1 by 16. Now you can do this by taking the LCM or you can do the direct division that we will do now. That is 0.5 for 1 by 2 plus 1 by 4 will be 0.25 plus 1 by 8 would be 0.125 and 1 by 16 will be 0.0625. Now, this we will add all this number, so we would get 0.9375, and we have got an answer, that is this 0.935 and 42. Our answer will be 42.9375. So we will write that is 42.9375. So finally, now our next and last example, that is a bit different than what we have done in these examples, the earlier examples. Here we have a decimal number, that is 25.265, and we have to convert it into a binary number. First of all, let's get over with this 25. So our format, we will write 25 here and divide it by 2. So 2 12s are 24. So you will get 1 as remainder. Now 2 6s are 12. So no remainder, 0. 2 3s are 6. Again no remainder. Now 2 1s are 2. So 1 remainder. Now this 1 is less than 2. So we will transfer it here. And our answer is, that would be bottom to top. So 11001, and point will be written here, I mean fraction part. Now let's get over with this fraction part, that is 0.265. We have to multiply it with 2. We have to keep on multiplying with it 2 until we get the perfect one. So 0.265 into 2 would give us 0.53. So we will transfer this 0 here. Now 0.53 into 2. So it would give us 1.06. We will transfer this 1 here. So we have 0.06. So we will multiply this with 2. So we would get 0.12. Now transfer this 0 here. Now this 0.12 into 2. So we would get 0.24. Now transfer this 0 here. 0.24 into 2. So we would get 0.48. Just transfer this 0 here. 0.48 into 2 would give us 0.96. Again transfer the 0 here into 2. 0.96 into 2 would give us 1.92. Transfer this 1 here. Now there is remaining 0.92 into 2. So it would give us 1.84. So transfer this 1 here. Now 0.84 into 2. So it would give us 1.68. Transfer this 1 here. And 0.68 into 2. It will give us 1.36. Transfer this 1 here. And so on. It seems like this will never end. So what is it? It is infinity. We have got an infinite solution. So what do we do? Now? So for that, we just have to write this answer like this. Here you have to go from top to bottom, right? So 0, 1, 0, 0, 0, 0, 1 1 1 1 like this. 0 1 0 0 0 0 1 1 1 1 and then dash dash dash, right? So this is your answer. You can write it like this. You don't have to do this much. Even if you have calculated 5 points, that would be sufficient. So this is called the infinity in binary, infinite binary fraction. So our binary classes, our binary chapters ends here. Thank you.